Hello, in this video we will be talking about Charles's law. This is another gas law and it investigates the relationship between volume and temperature. So, since we are investigating the relationship between volume and temperature, we must hold constant pressure and the number of moles of gas. So the amount of gas stays the same and the pressure of the gas stays the same as well. In holding these constant, we can see what effect volume has on temperature and vice versa. As the temperature of a gas increases, the volume increases. Conversely, as the temperature of a gas decreases, the volume decreases. We'll use the formula for Charles's law to actually look at this, but if we read the word definition, it just states again that if pressure and the amount of a gas are constant, the volume of the gas is directly proportional to its Kelvin temperature. And it's very important to note that that is Kelvin temperature, not degrees Celsius. So, if you run into a situation where you are given information in degrees Celsius, you need to convert that to a value for Kelvin. The formula for Charles's law, which you'll be applying to different word problems, is V1 over T1 equals V2 over T2. And what the V represents is volume, which would be in liters, and what T represents is temperature, which is in Kelvin. The subscript 1 indicates that that is the initial state of the system. So wherever the system starts out with, you want to record the volume and temperature from that particular point and put it with V1 and T1. Then there will be some change to a system. Either the volume or temperature will have changed, and then there will be new values for V and T, and those go into the subscript of V2 and T2. Since the volume is being divided by temperature in this case, and that's equal to a second volume over temperature, this is the type of equation we would expect when something is directly proportional. As volume increases, so does temperature, or as temperature decreases, as does volume. We can look at this graphically here with Charles's law, and you can see that temperature in Kelvin is on the bottom, and then the liters are on the left. Plotting data from Charles's law is actually how the theoretical value for absolute zero has been calculated. If you plot lots of points in the range of normal temperatures that we can experience or create in labs, and you follow that linear equation to where it equals 0 for temperature, we find that it's negative roughly 273 Celsius, or 0 on the Kelvin scale. But from this graph, we can see that as temperature increases, as does volume, and it's at a constant rate. And as volume increases, as does temperature. So this is just a positive slope linear line. Here's a sample problem. If you'd like to, pause the video, try to complete the problem, and then when you're ready, join back in. A balloon is left outside in the cold and has a volume of 2.5 liters at 283 Kelvin. What would the volume be when temperature increases to 320 Kelvin? Alright, the first thing we need to do is identify the variables in the problem. We are working with volume and temperature. Charles's law is the appropriate law to use when working with volume and temperature, so we will look at that equation. In this equation, we see that there's a V1, T1, V2, and T2, so we will pull those variables out to the side. Now, we need to identify those variables out of the word problem. So we go back and read the word problem. A balloon is left outside in the cold and has a volume of 2.5 liters at 283 Kelvin. What would the volume be when the temperature increases to 320 K. So the key words here that we want to look for is what would the temperature be, or what would the volume be. That indicates we're moving to a new state. So anything that comes before that is going to be the initial values. So we can see in the first sentence, the initial values are 2.5 liters for the volume, and the temperature is 283 Kelvin. The second sentence in the question is asking about the volume. So that is what we should be calculating in this problem. And the second temperature is 320 Kelvin. So now we have determined what 3 out of the 4 variables are, and if we go through using Charles's law, we can calculate what the final volume will be. So to continue the sample problem, I have pulled those 3 variables over to this slide, and we will look at Charles's law, and we'll start plugging in information. So we take V1, which is 2.5, and put that over T1, which is 283, and set that equal to V2 over 320. If you solve for the second volume, it is 2.8 liters. The question that we want to ask ourselves now is, does our answer indicate a direct proportion? Well, the temperature increased and we went from 2.5 liters to 2.8 liters. That is appropriate for a direct proportion. So you can always ask yourself and think about it conceptually if your answer makes sense within the context of the problem. Secondly, if pressure is constant, it is probably appropriate to use Charles's law. Again, we want to compare temperature to volume. You must use Kelvin for temperature. If you use Celsius, the change will seem very exaggerated. The Kelvin scale is a little bit longer in the ranges that we'll be looking at, so the difference is smaller on a percentage basis. So remember to use Kelvin for all of these calculations. Check the comments for further practice problems. Thank you.